demonstration is called the egg and flask. Basically what we have is a flask, a 500 milliliter flask. There's an egg, hard-boiled egg, sitting on top that's been peeled, and the water is being heated by a Bunsen burner. Actually, at this point, it's boiling, so think about what the molecules of water might be doing right now, and how that's affecting the conditions inside of the flask. Notice that there's condensation on the inside. It's actually steam rising from the water that's boiling and condensing on the cool surface of the inside of the flask up top. So we got a lot of steam inside. When I position the egg like this, you notice that it starts to dance around on top. So think about what might be building up inside of the flask. You may be thinking about pressure. How does that compare to outside air pressure around the egg? In a few minutes, what we're going to do is take the flask with the egg on top and put it into a tub that's filled with cold water. So you might make a prediction about what you think is going to happen when the flask is submerged into a bucket of cold water. Alright, at this point I'm about to submerge the flask into the cold water. And the egg actually falls into the flask. So can you explain why this happened? Using what you know about the kinetic theory, how that affects molecules, both inside of the flask, how that affects the pressure, how that compares to the pressure outside of the flask. Use all of that to explain why the egg goes into the flask, and think of one or two good everyday life applications.
This demonstration is called lava lamp. In this lab, we simply look at a working lava lamp and we try to use the kinetic molecular theory of matter to explain how it works. And we try to look at the molecules of two different substances and talk about convection. Before we start looking at how or why the lava lamp operates the way it does, we want to take a look at how it's constructed. If you've never looked inside of a lava lamp, at the top you have a sealed container with a small amount of space above the liquid. This particular lava lamp has clear oil, and it has something called paraffin wax, which is the purple globs of fluid that you see floating to the surface. What you'll also see is that underneath that closed container is a light source, and it also provides heat to the molecules in this lab. So what we pointed out in class was simply the cycle that the paraffin wax goes through in a lava lamp that makes it kind of groovy to watch and look at. If you'll notice, the purple paraffin wax starts at the bottom and slowly rises through the oil. When it reaches the top of the lava lamp, farther away from the heat source, you'll notice that the globs of paraffin wax tend to hang out there for a little while and then slowly sink back down to the bottom of the lava lamp. Make sure that you think about what those molecules are doing that are causing them to go through this cycle, and try to use what you've learned about convection to explain why and how the lava lamp operates the way it does. Good luck!
Okay, this demonstration is called the hot air balloon, and basically the materials that we use to make the balloon are very thin dry cleaning bags. They have to be the very thin kind because the thick, good, expensive bags actually won't work with this lab demonstration. We also use drinking straws to make the frame. Same thing here, we use the very thin drinking straws, generic thin ones, that don't weigh a whole lot. There are also 8 birthday candles that are positioned in the frame that has been made from straws. And those are the cheap birthday candles as well. And again, all of the materials are really cheap materials, really simple materials, because weight plays a very important role in whether or not this works. What we're going to do is light the candles on the frame, and then we're going to see if it actually works like a real hot air balloon. Okay, now all of the candles are lit. Notice that the volume of air inside of the bag is much bigger now. Before we lit the candles, the bag was deflated. Right now it's inflated. And actually the balloon is working because it is rising to the ceiling. So think about how the kinetic theory might play a role in making the hot air balloon work. What is happening with the air molecules inside of the balloon that's causing them to become less dense so they rise. This demonstration is called the air cannon. Basically what we have is an air cannon that we've made in Science Club, and basically is made from a cardboard box, rubber bands, plastic covering, and duct tape. And basically how this works is, from the back, when I pull the knob, it increases the volume of the box, allowing more air in, and when I let go, it forces the air out. Let me demonstrate. We've stopped Mrs. Esparza, who was about to leave the school building, and we've asked her to participate in our science demonstration.
Watch Mrs. Esparza's hair as she gets hit by the air cannon.
Okay.
You can laugh, Mrs. Esparza. Science is fun. Yay! Thank you. Your job is to figure out how we were able to get those molecules to move and hit Mrs. Esparza in the face from one side of the room to the other. One other trick you can do with the air cannon is try to blow out a candle from the other side of the room. So let's see how long it takes Mr. Harris to pull this one off. Here we go. Pressure's on.
Okay.
Oh.
And there you go. Okay, this demonstration is called dry ice, and basically what we have are some samples of dry ice for you to view. Dry ice is frozen carbon dioxide that exists at a temperature of -79 degrees Celsius or -109 degrees Fahrenheit. This is quite a lower temperature than the freezing point of water. Water freezes at 32 degrees Fahrenheit and 0 degrees Celsius. Do you think there's any molecular movement in dry ice? Actually, there is. The molecules do have quite a bit of energy, and they're gaining energy very quickly, and it actually skips the liquid state or sublimates directly into a gas. I'm going to put a few pieces of dry ice into this beaker of warm water that has some food dye in it. What you notice is that the vapors coming off are actually moving downward. Why might they be moving in that direction? Carbon dioxide is a very dense gas, and what we see here is that it's mixed in with water vapor, and because carbon dioxide is very dense, it's more dense than the surrounding air, so it falls to the ground instead of rising up into the air. Think of some everyday life applications for this.